Led by several tugboats, it slowly departed from the dock of Shanghai Jiangnan Shipyard. The third aircraft carrier was named the Plan Navy Fujian. The Navy's Fujian conducted its first sea trial after being commissioned.
抬升机准备完毕。2号位最后准备。风帆好，装置好。2号位允许起飞。
A 2-second launch with zero interruption. This is the electromagnetic catapult system, the Fujian. The electromagnetic catapult was chosen over a steam catapult because it does not require a complex piping system and occupies less internal space on the carrier. The force output of a steam catapult cannot be adjusted, which make a structural stress or damage to carrier-based aircraft. With electromagnetic catapults, more carrier-based aircraft can be arranged on the flight deck. During the launch of one aircraft, others can remain on standby, allowing more aircraft to take off in the shortest possible time and enabling a more complete air combat formation. With the adoption of electromagnetic catapult technology, the Navy has effectively equipped its carriers with a full set of core systems and initially formed a modern carrier-based aviation capability. The J-15T heavy carrier-based fighter can leverage its large payload and long range to conduct intensive strikes and has strong capabilities for both maritime and land-based missions. This slender rod is called the launch bar, designed specifically for the J-15T to enable catapult-assisted takeoff. It connects directly to the carrier's electromagnetic catapult, accelerating the tens of tons J-15T from a standstill to high speed within seconds and pulling the aircraft off the deck. The J-35 carrier-based fighter features an integrated design with a single seat, twin engines, and canted twin vertical tails. It is a new stealth carrier-based fighter independently developed by China, intended to support carrier groups in gaining air superiority and marking progress toward operations farther from shore. The KJ-600 is China's first carrier-based fixed-wing early warning aircraft. It supports catapult launches and can perform missions such as early warning detection, command and control, target designation, and operational coordination. I like to describe it using the image of a legendary figure, Nezzer. In mythology, Nezzer represents courage and a willingness to confront powerful adversaries, and we hope the aircraft will embody a similar spirit in future missions. From a global perspective, a mature aircraft carrier must possess strong integrated capabilities, including air superiority, sea control, early warning, electronic countermeasures, and anti-submarine operations. Military enthusiasts refer to the core set of carrier-based aircraft that support these capabilities as the carrier's 5-piece set. The carrier's 5-piece set is considered the core of a modern aircraft carrier's combat capability, consisting of stealth carrier-based fighters, multi-role catapult-launched fighters, fixed-wing early warning aircraft, fixed-wing electronic warfare aircraft, and anti-submarine helicopters.
平台上升。
This section is called the Integrated Catapult Control Station, informally referred to as the bubble. It serves as a key link connecting the flight deck, carrier-based aircraft, and catapult systems, and is part of the overall command chain. This station is primarily responsible for preparing the catapult system and conducting various pre-launch checks, including parameter input and final release. During numerous test and training missions, Navy pilots successfully conducted takeoffs and landings on the Fujian using multiple types of carrier-based aircraft. These missions verified the strong compatibility between China's fully self-developed electromagnetic catapult and arresting systems and various aircraft types, enabling the Fujian to achieve initial full-deck operational capability and laying a solid foundation for integrating different aircraft into the carrier strike group. Behind each second catapult launch lies decades of dedicated research and development in China's aircraft carrier program. As early as the 1980s, China launched an aircraft carrier feasibility study known as Project 891. This marked the first close engagement between Chinese military engineers and aircraft carrier catapult technology. Why was it named Project 891? Because an expert team was established in January 1989 to conduct a national-level study on the development of China's aircraft carriers and carrier-based aircraft. The name 891 also reflects the fact that while China's destroyer programs were already progressing well, the country still lacked an aircraft carrier. Therefore, from the perspective of naval technology development, studying aircraft carriers became a necessary step. A straight deck, steam catapults, arresting gear, hard to imagine? Although this carrier model was created more than 30 years ago, its design concepts were remarkably advanced and aligned with features seen on modern aircraft carriers. It is the display model representing the research achievements of Project 891. It features an angled deck and a Fresnel landing aid system. The deck displays models of the planned carrier-based aircraft, including a J-10 variant, a Y-7-derived early warning aircraft, and Z-8 and Z-9-based helicopters. The model also shows planned defensive systems around the ship, including the 857-gun system and Haehangi missiles, which were still under development at the time. From the side view, it is also equipped with an aircraft elevator, and this section represents its power compartment. At that time, the design used a steam turbine as its propulsion system. The equipment on the island structure is also fully represented. Overall, the model displays a range of features, such as the general layout and launch and recovery systems that a modern aircraft carrier is expected to have. During this period, we had very limited information available, with almost no external references to rely on. Access to information was highly restricted, so whenever we encountered even small pieces of foreign material related to aircraft carriers, such as operating procedures, manuals, reports, academic papers from naval institutions, or even brief articles, we examined all of them carefully. Through this process, we eventually developed a design plan that was our own and suited to our national conditions. Thanks to the efforts invested in Project 891, Chinese engineers became increasingly familiar with aircraft carrier design. Although the project did not directly produce an aircraft carrier, it continuously inspired China's long-term ambition to advance toward blue water operations. The Liaoning allowed Chinese engineers and naval personnel to gain hands-on experience with the technical details of large and medium-sized carriers, marking a breakthrough from having no aircraft carrier to having one. At this very dock, China's first aircraft carrier, the Liaoning, was officially delivered to the Navy. It was also here that China's first domestically built aircraft carrier, the Shandong, was successfully launched. The development of domestic aircraft carriers from nothing to existence to growing capability represents the highest expression of a nation's ship design expertise, construction capacity, and overall technological strength. When the Liaoning entered service, aircraft carriers around the world had already existed for a century. As China's first aircraft carrier, the Liaoning brought a sense of achievement and pride to the Chinese people, while also placing upon naval officers and sailors the expectations of the nation and the weight of significant responsibility. Faced with 22 decks, more than 300 vertical and inclined ladders, over 3,000 compartments, and several kilometers of internal passageways, nearly all members of the first Liaoning crew experience getting lost during their early days on board. Some crew members remarked that the journey of China's aircraft carriers began with simply learning how to navigate Just 2 months after the Liaoning entered service, carrier-based test pilot Diaming Ming successfully completed an arrested landing with the J-15, marking a historic milestone for the Navy's carrier-based aviation. The pose known as the aircraft carrier style quickly became popular across the country, leaving a strong impression on many people. It symbolized the ability to take off and represented the official beginning of China's aircraft carrier era. 1 year after the J-15's first successful landing, at a factory of Dalian Shipbuilding Group, the first steel plate for the Shandong was cut as a bright arc of light passed across the sea cutting platform. China's first domestically built aircraft carrier officially began construction, and that arc of light marked the start of a new chapter in the nation's carrier development journey. The Shandong was built entirely from the ground up, as it was fully designed and constructed independently. The first major challenge was hull construction, including testing the performance of specialized steel, and all equipment used was domestically produced. I am now at China State Shipbuilding Corporation, standing on the heavy gantry crane that was used during the construction of the aircraft carriers. From this height tens of meters above the ground looking down to my left is the 300,000-ton dock of the shipbuilding group. This dock is also a massive incubator for China's aircraft carriers. Stretching hundreds of meters, the dock must meet strict proportional, structural, and strength requirements to support aircraft carrier construction. Building on the experience gained from the Liaoning, the Shandong incorporated a series of design improvements based on the Navy's operational needs. Each refinement contributed to enhancing the overall combat capability of China's aircraft carrier fleet. The island serves as the command and control center of the entire carrier. Compared with the Liaoning, the Shandong's island design and information systems were further optimized and upgraded. The most noticeable change is that the Shandong's island is smaller, increasing the available flight deck area and allowing more carrier-based aircraft to be parked on deck, thereby improving sortie efficiency, an important indicator of enhanced combat capability.